So MASTER is an acronym for Microbiome Applications for Sustainable Food Systems through Technologies and Enterprise. And it's important for you to know just exactly what a microbiome is, I guess. So a microbiome relates to any environment in which you find microbes. The combination of the different microbes you find in that community, so bacteria, fungi, viruses, and so on, are known as the microbiota. And the various other components within that environment, such as the DNA within those microbes, the proteins, the lipids, the toxins they produce, and the environmental conditions and so on, are referred to as the microbiome. So understanding microbiomes can provide meaningful individual and public health solutions, impact on climate change, and help transform our food systems. However, for very many years, microbiome research focused predominantly on human health aspects, and the tools and new technologies that were being developed hadn't really been applied to the food chain and food industries and consumers. So to address this, the European Commission a number of years ago decided to fund 5 large projects relating to food systems microbiomes with a focus on food innovations, food consumers, food production. So MASTER was one of those, together with 3 sister projects known as Circles, Whole of Food, and Simba. And these were pulled together under an umbrella referred to as a coordination and support action. And this was known as microbiome support, led by Angela Sesic. Now, MASTER and the sister projects are innovation actions, which means that the research carried out needs to be of direct relevance to consumers and to the food industry by the end of the project or soon thereafter. So not blue skies fundamental research, but really meaningful research that can impact on people's lives almost immediately. And we and the other partner projects have been working very closely on a number of joint initiatives, including an approach whereby at Microbiomes for Life, you can find out about different aspects of microbiome research. And these tools and resources have been developed specifically for the public. So I'd encourage you to take a look at this website. Moving on and talking specifically about MASTER. So what was the focus of MASTER? So what we have done is to take a global approach to the development of microbiome products, foods and feeds, services, and or processes with high commercial potential. And now, rather than focusing on just one food system, we set ourselves the very high goal and target of looking at improving the quantity, quality, and safety of foods across multiple food chains, spanning the marine, plant and soil, rumen, meat, brewing, fruit, vegetable waste, and fermented food-related industries. In order to achieve this really considerable target, we worked together with another 28 partners from right across the EU. These included several different researchers from universities, from other research performing institutes, from companies, both large and SMEs, and other different entities to achieve this. And to have achieved those very considerable goals during the last 4.5 years was really remarkable, especially considering the fact that while we did get to meet occasionally, the vast majority of progress due to the COVID pandemic needed to be online. And despite that, we ended up being considerably successful. So as I mentioned, we're focusing on a number of different environments. And within those different environments, we've been developing new strains and consortia. So individual microbes or groups of microorganisms, new services and processes, new foods and feeds, new molecular analysis, and new databases and pipelines. And over the course of today's webinar, you're going to be hearing some stories relating to individual outcomes and impacts from those different research initiatives. But before getting into those, I'm going to provide some broad brushstroke overviews relating to just exactly what we were doing. More specifically, MASTER had 4 different work packages in which we carried out different types of research. Work package 2, where we focus on plant, soil, marine microbiomes. 3 for the rumen, 4 for food processing, valorization of waste streams and human gut health, and work package 5 focused on integrating new microbiome technologies for the food chain. The first of these, plant and soil microbiomes, what we did was to look at new microbiome solutions for improving traits of other crops. And this included improving nutrient uptake and providing control of pests and different microorganisms that are pathogens and can cause problems for fodder producers. We also looked to develop new microbiome-based diagnostic tools to detect those pathogens, and also to study the soil to predict how well they would respond to different types of interventions. From a marine microbiome point of view, the focus was to develop new sustainable feeds for enhanced fish growth, and also to employ, again, new microbiome-based diagnostics to assess fish health and to detect pathogens before they become problematic. The rumen space was one that we paid particular attention to, given its important impact on society with regards to sustainability and the control of things like methane and other greenhouse gases. And in this regard, we have made considerable inroads with regards to utilizing host genomics and breeding to alter the rumen microbiome in a beneficial way and to also impact the animal phenotype, so the animal features. We've defined the rumen microbiome at different stages of life in animals to improve efficiency, reduce methane production, and to improve the quality of the milk and meat that's produced, and also to develop new tools and models that we can predict how an animal will respond to different interventions. Work Package 4 was another very large endeavour and spanned a number of different areas. One of the most ambitious was to carry out a microbiome analysis or mapping of food processing facilities right across Europe. In essence, we collected thousands of samples from hundreds of food processing facilities, but rather than use old agar-based traditional microbiology testing, we pushed the boundaries and used DNA sequencing-based approaches to study those microbiomes and develop new tools and approaches that will be relevant to industry going forward and mean that these new technologies will become relevant very soon. We also look to optimize fermented food microbes and processes, improve biopreservation, develop innovative functional foods, and to prepare and develop minimally processed foods that are designed with a view to enhancing gut health. The final research work package is Work Package 5, where we carried out an integration of microbiome technologies. And in this regard, we've been developing, optimizing, standardizing, and validating a range of different microbiome analysis, which in the future can be employed to identify rapidly spoilage and pathogenic microbes within food processing facilities to enhance the safety and the shelf life of those foods. We developed new computational pipelines that facilitate the rapid analysis that's required in order to get the quick results to employ those new technologies, and also to develop new long-term resources that will be not just of relevance now and in 6 months' time, but continue to be of value to people right across the food chain.